Here's my audience. Are you an Algebra 1 or Algebra 2 student who needs a little more help with factoring polynomials that your teacher doesn't provide? I have always been a straight-A student in mathematics, so I understand that factoring polynomials is important to success in math. I'm going to teach you all how to factor different types of polynomials. Let's get started with a few examples. I'll start with a couple easy ones, then move on to a little more complex examples. Our first example will be to factor x squared plus 2x plus 1. The first thing we must do is find out all the whole numbers that multiply to equal 1. The two different choices for that would be 1 times 1 and negative 1 times negative 1. Now we have to find which of these two combinations add up to equal 2, because we have 2x right here. Okay, so 1 plus 1 equals 2, and negative 1 minus 1 equals negative 2. So that means that we must use 1 and 1. Okay, x times x equals x squared, so that has to be the start of our factor. And it has to be x plus, because if this is positive, then both of these must be x plus. X plus 1, x plus 1. Another way to simplify this problem would be to put this as x plus 1 squared, because these are the exact same thing, and it's much easier for your teacher to see x plus 1 squared. Now we're going to move on to another type of problem that is called a perfect square. The example is x squared minus 4. This is called a perfect square because there is no x, and there is just an x squared and a whole number at the end of it. All the numbers that multiply to equal negative 4 are negative 4 times 1, 4 times negative 1, and 2 times negative 2. We have to find the combination of these three opportunities and see which ones add up to equal 0, because there's no x in the middle. The obvious choice is 2 and negative 2, because 2 minus 2 equals 0. And of course, like the one before, x times x equals x squared, so that'll start out our polynomial. And then we put x plus 2, because this is a positive 2, times x minus 2. A way that we can check this answer would be to multiply out to try to get this answer again. So we'll take x times x, which equals x squared, and then x times negative 2x, which equals negative 2x, then 2 times x, which equals positive 2x, and then 2 times negative 2, which equals negative 4. Okay, now this negative 2x and positive 2x will x out, and so those will be gone. And then we have x squared minus 4 remaining, and that is the exact same thing that we started out with at the top. Now we're going to move on to a polynomial of degree 3, which means that the polynomial will have an x to the third in it. Our example is going to be x to the third plus 3x squared plus x minus 1. This may look rather intimidating at first, but it really isn't if you take it step by step. We know that x squared times x equals x to the third, so that is how we will start out our polynomial, our factoring. The last number of each factor must be a whole number that multiplies to equal 1. The only possible solution is negative 1 times 1. We now have x squared minus 1 and x plus 1. However, this is not yet the correct answer. We must make sure our answer multiplies to contain 3x squared plus x plus 1. So we need to find something to multiply times x to equal 2x squared. Our only possible solution is to this would be 2x. we now have the answer of x squared plus 2x minus 1 times x plus 1. Let's try another example. It's going to be x to the 4th plus 2x third plus x squared. When you may look at this problem and wonder what you can possibly do to factor it. When you see such a high degree polynomial with no whole number at the end, you can probably divide something out of it. In this situation, we can take out x squared because each part of the equation contains at least x squared. So what we'll do is take x squared out and then parentheses x squared plus 2x plus 1. It now looks like a very simple example to solve, which it is. We first have to find a pair of numbers that multiply to equal positive 1 and add up to equal 2. The only possible solution to this is positive 1. So what we'll have is x squared, and remember x times x equals x squared, so we'll have x plus 1 x plus 1. Okay, just like that problem that we did before, we can put x plus 1 squared, so it'll be x squared parentheses x plus 1 squared, and that's our answer. Okay, we'll do one final problem before we conclude this lesson. Our example is 5x squared plus 10x plus 5. When you see this problem, you can see something that's very common between the numbers. There's a number that goes into all these numbers, and that the highest number is 5. So we'll take a 5 out, just like we took an x squared out that last problem. So 5x squared divided by 5 equals x squared. 10x divided by 5 equals 2x plus 2x. And 5 divided by 5 is, of course, 1. Does this look like a very similar point that we were at before? Okay, we'll take 5 parentheses, then x times x equals x squared. And then we have to find the two numbers that multiply to equal 1 and add up to 2, which is 1 and 1, just like before. So plus 1, or 5 parentheses x plus 1 squared. And that's our answer. Now that we have finished our round of examples, I want to remind you that factoring is a very good part of Algebra 1 and 2. Becoming good at factoring takes a lot of practice and a lot of time and effort. It doesn't come naturally to most people. I now encourage you to practice more factoring and wish you the best of luck in your algebra classes. Thank you. Here's my audience again.